Welcome back to another AP Pre-Calc video. I'm Mr. Hibble. Today we're looking at another section of 3.14. This is the second video of a three-part series where we're discussing polar coordinates. Polar coordinates, remember, is always an r comma theta, a radius comma some angle that makes you rotate that radius to where that coordinate would end on that plane. So example one, top kind of talks about what we're about to go through. But example one says, first let's illustrate the triangles by drawing a picture. So what we have is root 3 and pi 6. That is the radius, and that is theta. So I know if I draw a triangle, the angle is pi 6, and the radius is root 3. Okay, but I don't want to think about the radius as root 3 right now. Let's think about the normal unit circle. We know unit means the radius is 1 normally. We know that, okay, if it's 1 and we're at pi 6, the coordinate is root 3 over 2 comma 1/2. Well, that's an x and a y value, so I could put those on our triangle, horizontal distance and vertical distance. But again, we said the radius is different. We said the radius needs to change. It needs to now change so that it is root 3 instead. Well, what makes 1 go to root 3? Well, multiplying it by root 3. So root 3 over 2 times root 3. We could simplify that. 1/2 times root 3. We could simplify that. And now we have the rectangular coordinates for the polar coordinate that we were given. 3/2 comma root 3 over 2. Okay, we took a polar coordinate and we converted it to an x comma y. Let's go ahead and look at another example. Let's go ahead and look at just example D right here. Again, if you need to draw these triangles, definitely do so, but you'll start to notice a pattern. We'll discuss that pattern at the end. We'll discuss the formulas you can utilize to make this process super simple. But this is the generic idea. Start with a unit circle, start with your angle. Think about the coordinate and what the x value and the y value must be. Think about how we must change that triangle to change the radius. Realize that's really just taking 1 and multiplying it with the radius. So that means these other sides just multiply with whatever the radius value is. Oops, this one should be 1/2 times 2 root 3. And then just simplifying, that can be the hardest part sometimes, making sure you understand how that works. 2 over 2 would cancel. 1 times root 3 then is just root 3. I'm looking at a root times itself. Root 3 times root 3 is 3. The 2's still cancel here, so there's a value of 3. Make sure we write this as an x comma y value, root 3 comma 3. That is how we can go from polar coordinates into rectangular coordinates. Rectangular is just our normal x, y. Let's look at this idea, but now going the reverse direction, taking a rectangular coordinate and changing it to polar. Well, again, you might think about this stuff as triangles, but instead of being given the hypotenuse, the radius, and the angle of it, you're now given the x and the y direction, the opposite and the adjacent side. So let's draw our triangle here. We have an x, we have a y. They're both negative. That means we're going to be in the third quadrant then, where -6 is here, -2 root 3 is here. Well, if I need to know the radius is the hypotenuse on this triangle, so we could go ahead and use Pythagorean theorem. Again, sometimes the simplifying is the hard part for us, so be careful as you go through this. -2 squared is 4. Root 3 squared is just 3. 36 plus that would be 12 is 48. We take our square root. We're assuming the radius is positive here. You could rewrite that square root as square root of 16 and square root of 3 in order to reduce it. Square root of 16 is 4. Square root of 3 is still just 3. So we have now found r, the radius. In order to find our angle theta, though, you need to be careful. In order to find theta, what trig function can we utilize? Well, we had the opposite side. We had the adjacent side. That tells me I could utilize tangent, which is the y value over the x value. If I reduce that fraction, then that tells me that tangent theta is now equal to root 3 over 3. Remember, tangent on the unit circle is just the slope, where at each of these different spots on the unit circle, it has each of these values. We know the slope of a horizontal line is 0. We know a vertical line is undefined. We know at pi fourths it's 1. And the steeper of the two remaining is root 3. That is at the pi thirds. And root 3 over 3 is at pi 6. So what we find is the angle in this case we need is pi 6. But be careful, because that's not the right answer. We know that we drew this triangle in the third quadrant. Pi 6 does not get us to the third quadrant. So we need to fix that. How we can fix that is by adjusting our angle. We can make the angle move to the third quadrant instead. Pi 6, if that were in the third quadrant, it would be at 7 pi 6. So now we have our coordinate r comma theta, which is 4 root 3 comma 7 pi 6. That is an equivalent coordinate in polar form to the rectangular one we were given. Let's look at one more example just to make sure that we are strong with this idea. Again, all we did was use Pythagorean theorem and tangent. That process will stay the same for this. So let's skip straight to Pythagorean theorem. Notice we would be in the first quadrant here, as both the x and the y are positive. So, okay, r squared, that's 81. 3 squared is 9 times square root 3 squared is just 3. 81 plus, what would that be, 27? 81 plus 27 is 108. Square root of 108, then find a perfect square that goes into that. And I believe you could find 36 goes in 3 times, giving us 6 root 3. So, okay, we have found the radius. We still need theta, and again, that's just found utilizing tangent of the y value over the x value, right? We know tangent is y over x. Reduce your fraction again, and it looks like, in this case, we're still going to get theta equals pi 6. But what quadrant were we in? Let's make sure we have the correct angle. In this case, we had a positive x, a positive y. That's the first quadrant. Pi 6 gets us to the first quadrant, so we just need to rewrite our angle. There is our form for r comma theta then. There's our polar form. So one thing I mentioned is there's easy ways to do this. If you want to go polar to rectangular form, all we did is we took the radius and we were multiplying that with the different x and y coordinates on the unit circle. Well, the x coordinate on the unit circle is really just cosine, and the y value on the unit circle is just sine. So if you want to find x and y, you can utilize r times cosine theta, and y equals r times sine theta. If you want to go in the reverse direction, rectangular to polar form, we said tangent theta equals y over x. We found the theta value utilizing that, really taking inverse tangent to get theta by itself. We also saw that r squared equaled x squared plus y squared. In other words, r equals x squared plus y squared. And we did limit it to just the positive case in this problems. There is our 3.14 video. Again, this is the second in the series. Stay tuned for other videos coming your way. Thanks for watching.